Alright, last example here in this section. Word word problem here. You ride an express bus from the center of town to your street. You have two payment options. Option A, buy a monthly pass and pay $1 per ride. So buy some monthly pass and then still pay $1 per ride. Option B, just pay $2.50 per ride. That's it. A monthly pass costs $30. And then how many rides will the total cost be the same? Okay. So, if you're too quick, you might think, okay, $1, $2.50, and then 30. $X plus 250Y equals 30. Now, you have to read into the problem. There's an option A and an option B. So there's actually two equations here. Option A, think about it. Buy a monthly pass and pay $1. Okay, and what does and mean in math? It means plus. But let's think about our variables first. What should X mean and what should Y mean? Well, what don't we know? We don't know how many rides we'd have to take, and we don't know the total cost. So which one would be which one? X would be the number of rides we take on the bus, and Y is the total cost. So let's make our first equation. Option A. How much money we spend is equal to a monthly pass and $1 per ride. So monthly pass, they told us, was $30 plus we pay $1 per ride, $1 per every X. So this is option A. Total cost is $30 plus $1 per every ride. Option B is just pay $2.50 per ride. So what's more efficient? The total cost is $2.50 per ride. There you go. So basically it says in the end, when will these options be the same? Okay? When will these two things be equal to each other? Meaning, if you graph the first one, it may look like this. If you graph the second one, it may look like this. When will these two things be the same? Right here. This coordinate right here will be the same. Okay? That's the only time. So basically, take out your calculator, type in the first one, type in the second one, and then hit graph. Now you probably won't see everything. You have to change up your window. Well, your y-intercept is 30, so you have to at least go up to there. Probably go farther than that, maybe 50. Put your y's up to 50. Change your x's, make them go maybe a little bit farther. X goes to 10 or 20, okay? Change up your window so you see everything. You see this whole graph right here. When will these two be the same? I'm going to teach you that a little bit later. So your calculator will actually find the intersection of these two things right here. Okay, so let's look at what they said. So they put it out in words, and then they got the same thing as we got in the graph here. Here's our graph. So we got one line going this way, we got one line going this way. That dot right there is 20, 50. Now you have to be able to interpret this. What does 20 mean? What does 50 mean? It's a word problem. 20 is your X, 50 was Y. Well, what did you say X was? X represented the number of rides. So 20 rides, and what does Y represent? Total cost. So if we ride 20 times on this bus, we pay $50 total. And if we ride 20 times for option B, that's option A. If we ride 20 times for option B, we also pay $50. So basically, that's it. We check it, and here we go. The total costs are equal after 20 rides. Correct answer is B. So make sure you know how to do a word problem. Basically, in a word problem, you have one equation, two equations. It's a system now. Solve them both. Graph them and see where they intersect. Okay, I'm going to teach you how to do it in the calculator. Alright, that's it for section 1.